Welcome, everybody. We were just offline talking about the hopeful effects of Mosaic and what that's going to be able to do for us all in this space. And there's a lot of optimism around it, particularly with the prospects of adding electrification and distributed electric propulsion and all the control benefits and safety backups that come along with that. So it's going to be a wonderful thing. Hey, Tom, great to see you. Thanks for being here.
Hey, Andy, hey, I'm going to be around for the first probably 20 minutes. I need to punt. I'm in the Amex Club in the Seattle airport. So,
Oh, right. Well,
yeah,
Tom.
did you have to
I'm
sleep on
back
the
to the
floor
city.
last night?
No, I slept at the Hampton Inn,
Thank
but
goodness.
I don't feel as well as sleeping at the Holiday Inn. So,
Got it. Well,
four,
you,
four,
you,
four,
you look
four
fine.
solid hours of sleep. So.
You got in a tight nap there. That's good. That's
Yeah,
good.
yeah, it was a nice long, extended nap.
How does everybody foresee Mosaic affecting them? Any thoughts about how that's going to work? Tom, are you hearing excitement from your clientele?
I'm not, although I'm going to be, um, you know, not that it's going to affect the unmanned world too much. I'm going to be down in Huntsville next week at the Unmanned Industry Show, and then at Air Force Association, and then the AAM show. So hoping to pick up some intel over the next couple of weeks, being around airplane people. Again, um, so there. Just as an aside, not that it has a lot to do with man, but 2 weeks ago or a week ago at the the commercial UAS symposium in Vegas, there was a lot of excitement there about all the new changes coming on that side of the house. So I think there seems to be a lot of energy out there, um, at least on that side. So it'll be interesting to see kind of how the energy picks up on the man side.
Yeah, for sure. Here's a question I just want to throw out to the group. There's just a ton of great kit-built design aircraft that are produced in low volumes because they're it takes a good amount of time for folks to commit to building an aircraft in their hangar or garage or whatever. But is Mosaic going to open up production for all these kit aircraft that are already out there with these great designs, and is that going to push a lot of new small aircraft designs out into the market?
I think that's a great question, honestly. I mean, I like to use Epic Aircraft as a good example of one that started as a kit plane, and then they went and turned the crank on making that a certified aircraft. I think they're one of the few that's made it in that market, right?
Yeah. Yes, exactly. Yeah, I kind of just am wondering is there going to be a flood of all these great design small aircraft that start to show up over the next year or two that fit within Mosaic, and then could they, how hard or easy is it for them to start thinking about some slight redesigns to put in some motors and batteries?
Yeah,
Well, sorry to interrupt, the EAA, Experimental Aircraft Association's monthly magazine just arrived, and Mosaic is on the front cover, and they're just delirious about Mosaic. Apparently, they've spent with other organizations the past 10 years lobbying for this. And to answer your question, they think yes, a resounding yes, including some existing flying airplanes that are in Europe that could come over immediately under Mosaic. And they think there will be more designs as you were wondering about. So we'll see.
That's right. There's aircraft already certified in Europe, right? That will now be able to slide over here.
Andy, this is Tom. I'll jump in. I think that I completely agree with that statement. However, I think the access to capital issue within the aerospace market, specifically small things that fly, is going to be a challenge if these operators want to scale up. I've been hearing from my clients that the money is just not there unless you're like Joby or Archer or your Boeing going into capital markets. The money is just not there unless your cap table's at $1 billion.
Yeah. Yeah. And if you look at the stock values of some of these companies, like you mentioned, they're at least for now, they're sliding a bit, unfortunately.
Yeah, but those are companies that are going after commercial, I mean, regular commercial market.
Well, that's what they pitch it as. A lot of that is being military funded. And you're seeing, I think, more of
Yes,
a shift there in how things are being marketed.
yes.
Just publicly, the front facing, greenwashing, I think, is consistent, but there's a lot of military funding behind all those things.
Yeah, and there's capital there. But
Yep.
yeah, what about all these little guys that have an idea and when they enter the mosaic market? Yeah, it's particularly if they want to scale up. So we'll see.
That's what your 401k is for. Been there, done that. So uh
Tom, you've got a Mad Money account in there, don't you?
oh, it was definitely mad, Andy. I'm not, it was mad. Yeah. We obviously can have that talk over a couple of scotches sometime.
Count me in.
Mm.
Definitely count me in. Hey, I was going to talk about events. We've got the Transformative Vertical Flight event coming up in San Jose. Well, not coming up, but in a couple months here in January. I would love to go there. I'm not sure if I'll be there. Is anybody planning to be out there?
Probably.
You and your gang will be there, Matt? Yep. Tom, you're going to be out there?
Yep.
That's always a great one. Those are our people.
Yep.
And I kind of like it when it's in San Jose. I feel like it's a good draw there. You've got the whole Silicon Valley base.
Yeah, you've got
Phoenix
it's local to a lot of movers in the industry.
Yeah. Yeah. So I think that's going to be a good one. And then we've got sort of the big VFS event right here in my hometown in May will be the annual forum in West Palm Beach, Florida.
I'd be there too.
Perfect. What other events are people thinking about going to that we should be thinking about checking out?
There is an AAM event in Virginia Beach coming up.
The AUVSI?
Yes, the AUVSI AAM event is coming up. I think that's in September here. That's September 24th and 25th.
Okay.
So, and then
I went 2 years ago. It was a pretty good group.
Yeah. So that's I'll be there. That's why I know about it.
Yep. Good.
We were at
that
the eVTOL Insights meeting in Germany this week, and we've had good engagement here in the US as well. And they're kind of a newer organization, but a lot of the same people show up at those events.
Excellent. Okay. Good. Good. Well, we got some good stuff on the horizon. Are there any new folks that haven't been with us before or in a while that would be interested in introducing themselves or just telling us what you're up to? We always love new friends.
Yeah, good morning, Andy. Good morning, everyone. So first-time attendees, my name is Rob Haywood. I'm with W.L. Gore and Associates. I've been here for about 28 years. I'm new to aerospace, though, so I've only been in the aerospace and defense team here about a year. And my focus is on electrification, so trying to take Gore technology and solve some of the challenges of electrification, high voltage, high temperature challenges that are there. So thanks for having me, and nice to meet you all.
Yeah, I'd love to learn more. I think I've had some of your jackets and boot products, but I'd love to learn more about your interface with aviation and what we can all be doing to help you. That's what this is all about, is just kind of helping cross-pollinate ideas. And the more we know about what we can be doing to help you, the more we can act on that. So
super.
Stay close with us. We're here to help.
Awesome.
And they have the best business card holders in the business, Andy.
Really?
Oh, they've got these Vortex business card holders. They are phenomenal. If you see the Gore folks, you got to ask for one.
And I'm
All right.
embarrassed. I don't even have one myself. I thought you were going to say, in some of our shows, we hand out tanks. I'm sorry, ducks, like rubber ducks in the shape of tanks, if at like a land defense show. We have like helicopter and like a Flora rubber ducks too. I thought you were going to go there, but there you go.
Oh, there
Yeah.
it is. Outstanding. Well, I've got a bunch of business cards laying around like a schlub. We got to talk, man. That's fantastic. Uh, oh, that's sweet. That's sweet, Tom. Yeah, we all need one of those. All right. That's good to know. Well, perfect. Well, welcome. Anybody else that's new that would be interested in introducing themselves?
Yeah, hi, Andy. Joe Hartman, Fort Lauderdale, Florida. You and I spoke personally,
Yep.
and now I got the nice invite for the first commercial virtual meeting. So thank you for that invite, and here I am. I'm an aviation consultancy for about 30 plus years, mostly pilot training and simulation going forward. But I'm now involved with two projects. One project is working with the South Florida Miami-Dade Aviation Department for analyzing the airspace for AAM for the eVTOLs. Not at the drones at this time, but the eVTOLs. And that consists of Fort Lauderdale and also West Palm. And then on a side note, I am starting up with a couple of principles for hydrogen going forward to produce it and then to make it mobilized, and then refueling, if you will. So that's a new startup. So I'll have more information used, and I'm going to provide that more information, I guess, in High Sky. But if you ever have another commercial aspect in terms of hydrogen, another fuel source, I would like to participate in that. So thanks for the invite, and hello, everybody.
Yeah, thanks for being here. You got some fun stuff on your plate. Before we introduce our speaker, any other new folks or anyone that hasn't been here in a while that would like to introduce themselves or what they're working on?
Well, I'm new to this group, but I've been a member of the Vertical Flight Society for, I guess, a couple of years now. I'm in Tampa, Florida. I'm a civil engineer. I mainly build modern roundabouts when I can. But I'm an Air Force brat, so I've been around planes since I was very young. And I've liked electricity since I was very young. So now we have a convergence. Regarding the most direct kind of engagement, aviation, the closest I came to being able to afford my own plane was a box of parts called BD5, which was a wonderfully efficient airplane kit back in the last century, which didn't come to fruition for me or most people because the engines weren't up to it. Anyhow, I think this is a great organization, and I'm glad, Andy, that you sent me an invitation. Also, I'm somewhat interested in perhaps starting a chapter here in the Tampa Bay area. Not to steal from any other chapters, because you can belong to more than one, but it requires 5 people to be committed to serve as officers and members for 2, probably 3 years. But Tampa International Airport and St. Pete Airport are both very much aware of AAM and active in that space. So there will be activity here in the Tampa Bay area.
So Vertical Flight Society has a sort of a posting board called Hover that you can communicate with folks with. And I'm going to drop the URL. Yeah, I just put it in the chat. That's a great, if you have interest in pulling a group together, that's a good go-to place to get started to communicate with other VFS members that are also in on the Gulf Coast that are interested in joining with you. And they're out there, and that's a good place to start finding them.
Got it. Thanks, Andy.
Yeah, absolutely. And anyone else before we get started?
Just to say to Ken, if you don't mind leaving your email in the chat, I'll reach out to you. Being in the South Florida side on the East Coast, maybe we can collaborate.
Yeah, sure. Who's that?
Joe Hartman.
Okay, Joe, you're just on. Oh, good. Yeah,
Yep.
we can we can fill balloons with hydrogen.
All right.
If you have any excess production, I will do
Gotcha.
that right
I'm gonna
now. Thank
I'm
you.
gonna I'm gonna watch for the news at 5 on the incident.
Yeah, right.
Starts with Florida man.
Yeah, exactly. Exactly. All right, we're 20 after the hour, so I'll get us going. And could I ask everybody a favor? We could all mute, then we'll keep the background meows, barks, and clicks at bay. Appreciate that, everybody. Well, we've got a great presentation lined up for today. We've got Matt Farides with Evolito. He's the Vice President of Business Development, and I think we've all seen Matt quite a bit lately at VFS events and others as well. Sounds like he's just zipping all over the planet, just back from Europe, and we're lucky to have him here today. He's the Vice President of Business Development at Evolito. He's got over 20 years of experience in engineering and aerospace. He's worked on safety and flight critical control systems, power generation, and power distribution technologies. At Evolito, has been focused on driving installation growth of their electric motors and high power propulsion systems. And today we're lucky enough to have him with us. He's going to be talking about the key enabling technologies at Evolito, such as their axial flux motors and motor controllers, and updates on their products and certification pathway. So with that, take it away, Matt. Thanks for being here, buddy.
Thank you, sir. Give me just a second to get the presentation up.
Take
And
your
give me a
time.
shout when it's oh, see,
Yep.
that's the wrong. Is that the right?
We'll do. Not yet. I told you it only
See,
works when
it only
we're trying
works.
yeah.
So I need to take
This
it
one I can see the notes.
right. And so if I take it out of presentation mode.
So I don't see anything right now.
Yep. Yep.
I have this post-it for everyone else. I have this post-it note I have to keep on my computer with all the steps that you have to use on Zoom is a pain. So I've got like 8 steps here to be able to share
How
a
about now?
presentation. Nothing right now.
Wow. This is amazing because we just did this.
I know, I'm telling you, it's not you, man. It's always like this. I can see sharing, but I can also see your notes.
Yeah, so it wants to share that screen. Let me do it by so we did this and it worked a minute ago. Let's do it
I know
by screen instead of by how about that?
Yes, perfect. That looks outstanding.
Okay. You had to do it differently than before. Okay, anyway.
Yeah.
Thanks for having me, Andy. I appreciate being here. It's been a good working group in general. VFS has been good to us, and we appreciate the invite. I will say it's just been kind of a fun industry to be a part of for the past couple of years. Andy and I were chatting about this before you all joined. Evolito has been super busy the past, especially 12 months. I mean, we're working on applications that span all of the images you see behind me and on the screen there. Maybe a little bit too broad, quite frankly, but that's how the industry has been with companies sort of coming and going. But we seem to be narrowing in on some optimized designs. And so hopefully we're going to have a little bit more focus, and we'll be able to talk a bit more publicly about some of the jobs we have ongoing once those are publicly announced. But we've got some big stuff coming. Hopefully in the next couple of months we can talk about by the end of the year. As far as questions, I know we usually wait for the end, but I would just assume people kind of jump in so that the content is relevant when the questions come up. I will probably spend a little bit more time talking in tech details than I get a chance to at the big forums. So feel free to raise your hand or holler and jump in. We can talk about it on the fly. But again, so it's been very busy for us. I'm happy to be here because we only get so many chances to actually sit down and talk about this stuff in forums where it's functional and productive conversation rather than just passing conversations in hallways. So this is a good forum for that, and thanks for that. And just confirm that updated. I won't ask again. Okay, thank you. So we're just about 4 years old. We spun out from YASA in 2021. At that time, YASA, and that's not EASA, that's YASA, which stands for Yokeless and Segmented Armature. Clearly engineering firm, right? So they continue on their own journey, scaling to huge numbers in support of Mercedes-AMG. And the takeaway there is that this technology is very robust. We can't talk numbers necessarily, but massive investment over the past 15 years from VCs, customers, partners, countless hours of engineering time, product improvements, industrialization on that product line. So we get the benefit standing on the shoulders of over a decade of improvements on that product line before we were even created. And so when YASA was created, part of the deal with Mercedes was for us to spin out as a separate entity. There's no cross ownership, but we do maintain an IP agreement with YASA. So as they industrialize this to huge numbers under Mercedes, we take benefit from that. And as we drive product improvements, both in performance, quality, we got a little bit of a different focus because aerospace drives different quality requirements than the automotive product did. But that drives us to higher power density in general, and they can take benefit from that. So millions of hours of operating time on this motor topology for a product that's very high performance and very manufacturable from day one. And so although we take that benefit from YASA, our mission's a bit different. So anyone who's worked both inside and out of aerospace will understand that the business model of aerospace companies are fundamentally different. So Evolito was founded with the clear intentions from day one to build certifiable high quality products at high rates. And this enables the aerospace industry to make a step change in performance compared to today's machines. So the investment in infrastructure, testing, production facilities, certification capability, this was all planned from day one. So it's part of our business model as we spun out from YASA, which is quite different than some of the other motor companies in this space. A lot of that's also been implemented since. So there's some great videos on our website. I may be able to drop some of those in the chat. I should have had it prepared ahead of time, but from our website, you can find some of the videos of our manufacturing facility. And there's some great shots in there of just how far we've come. So in only 4 years, we've got what I would call a world-class facility. And this coming from a guy who worked at UTC and Raytheon and other companies with world-class facilities. Evolito was the first electric propulsion company to achieve DOA in the UK under the CAA, which is the equivalent of the FAA there. And we're now solidly down the path of POA, which is production organization approval. Our assessment is currently ongoing for that. So we intend to be the first for that as well. And we also achieved AS 9100 this year, which puts us in a great place to scale to full production of flight-worthy hardware in the very short term. So we've got some hardware that's already safety of flight. We have flown on a couple of demonstrators that have not been announced publicly that they used us for propulsion. Hopefully those will come out and you'll understand who those are in the near term. But we are already producing flight-worthy hardware in our factory, which is separate from YASA. So I'm going to reference YASA quite a lot here because I think it helps to give the idea that we're not just a startup and we're not starting with new technology, but we are completely separate. We have our own production facilities. We have our own processes, et cetera, et cetera. So talking a little bit about the product line. Clearly we started as a motor company with a head start from YASA, but we have spent quite a bit of time in other spaces, and I can talk a bit about the motor topology in detail, the MCU topology in detail. Start with the motor. So the reliability point, the stator design that we've got, and I'll show you a picture here in a minute, eliminates the possibility for adjacent phase shorts. We're also able to physically segregate within the machine multiple channels without interleaved windings. So fundamentally different than what you're used to. We actually can create a more redundant system within one machine than is possible with a radial flux machine. We also use no iron cobalt materials. You know, those are like 60 times more expensive than cheap iron pieces. Fundamentally, this motor leverages lower cost subcomponents than traditional motors do. And it's like an order of magnitude. It's not a small amount. Liquid cooling of the stator allows for much higher sustained power levels compared to air cooling. And fundamentally, the dual rotor axial flux topology, which you'll see an image of in a minute, provides a second order effect. So specific torque scales with radius, and that needs to sink in a little bit. So as you increase the diameter of the machine, specific torque increases with an axial flux machine, whereas a radial flux machine is dimensionless. If you need more torque, it's got to grow axially or radially. With us, the larger the radius is, the higher the torque per pound. Evolito has invested heavily in our in-house motor control capabilities because we know we need DAL-A controls in order to enable eVTOL applications. I'll talk about that a little bit more in a bit. And we've implemented certifiable common mode fault mitigation, which is kind of an industry concern. We have several patents pending around that within our motor designs. And of course, all these systems are bidirectional, so we can run just as well as a generator. I would love to add another picture to this soon, showing a fully integrated propulsion system. We get a little bit of a bad rap from people who don't, I guess if you're at an aircraft level, you hear liquid cooling, you think about the complications of how to integrate that. Several of our EPU, and when I say EPU, that's electric power unit. The industry calls it electric engines. There's a couple different names for it. But our integrated EPUs, in many cases, we can eliminate the need to connect liquid externally. So we can handle that liquid internally in our motor and have a heat exchanger system built into our EPU such that, from your perspective, it is still an air-cooled system. Once we have some of those that are public, we'll be able to share pictures of those. I just can't do it quite yet. Diving further into the machine itself, if you can see my cursor, you'll see rotor plates on either end. That's that dual rotor system that I mentioned. Magnets are just inboard of that. And then the magic happens, most of the magic happens in that stator section in the center, where you see those stator plates holding onto the stator housing and holding those pole pieces in place. So that the center of the machine, the stator, is liquid cooled. The motor segments themselves are extremely lightweight, very simple, highly manufacturable. A lot of the IP in this machine is around manufacturing technologies. It's not that complicated a machine. Otherwise, it's quite simple once you understand the details of it. The stator topology provides physical separation between phases. I alluded to this. This adds to reliability and long life, reduces the possibilities for cross-phase shorts. We're also able to reconfigure that stator quite easily compared to other topologies. So we can rewind those pole pieces for different motor configurations. We can separate it into single or dual channel configurations. That twin rotor topology provides a means to balance the forces of the assembly to minimize active material mass. And we're managing the air gap on both sides with the bearing and hub assembly, which is not shown in this image. You can see some pretty good exploded views. If you look at YASA's website, they've got a moving, expanded view of it. And we've got some views of it as well on our website. So the use of copper, iron, and rare earths are minimized throughout this design, which makes us fundamentally cost competitive compared to traditional machines. We leverage advanced lightweight materials where practical. So you'll see a lot of use of composites instead of steel or iron. There's actually quite I'll say it's very, very limited how much metal is in this machine compared to traditional motors. So to talk a little bit about the differences in the stator side, if you look at the top images, a traditional radial flux stator, I know this is an older system. I get beat up by this a little bit because, quote unquote, nobody builds machines like this anymore. But from a past role, if you look at my LinkedIn history, some of those companies still build machines like this and are very competitive. But in general, the takeaway is the end turns in a traditional machine put your phases quite close to each other. And so this increases the probability of insulation breakdown. Whereas in our system, the phases are physically separated. So we've got the ability to, I'll say, there's a failure mode that's just not really possible in our machine compared to traditional machines. There's also a cost driver there because in a traditional machine, the quality standards for wire insulation and dielectric are higher because of that chance of having face-to-face shorts. So the physical isolation between phases, in our case, is highly improbable to a point where actually the insulation is somewhat redundant. It's really there it's belt and suspenders, I'll say. The machine would run without wire insulation due to the nature of how it's designed. And so even in the unlikely event of a short between adjacent wires within a coil, the motor will still operate just with a slightly lower voltage, and we'll detect that and we can operate in degraded mode. So this is just one example of one of the many fundamental design features which enable this motor technology to achieve what we're considering a flight critical 10 to the minus ninth safety standard. Under NDA, we can talk about a bunch more, but this stuff has all been cleared. And another example, just to kind of show, and yes, I've stolen this directly from YASA. You can see a YASA style stator on the left with an equivalent radial flux machine on the right. And this is to scale. The axial flux machine takes up about 50, in this case, about 50% of the volume of the radial flux machine. And again, this is legacy. So there have been some improvements in both since. We don't really have so much. There aren't so many aerospace companies that are posting pictures and images of their motors for us to compare against. So check back in a year or two and hopefully we'll be able to compare them more directly. And it's not to say that axial flux is better at everything, but if you're talking torque density and volumetric efficiency, it's really hard to beat. So to be clear, this 50% is where we are today, and the technology is capable of quite a bit more. Both Evolito and YASA separately, and because we share IP, are working on improvements to this machine. The performance envelope will be improved over the coming years. If you go and check LinkedIn and look at YASA's LinkedIn from about a month ago, Tim Woolmer put in a post, which is what you see a little screen grab of on the right-hand side there. They took a machine that's in the ballpark of our D250 or D500, ran it quite high in RPM, and they pushed that machine to 550 kilowatts. And the machine only weighs 13 kilograms. So I'll say that again, 550 kilowatts in a 13 kilogram machine, which gives you over 40 kilowatts per kg. Now, we can't talk about how they did that, but that was actually run at a third party. I think it was Drive System Design ran that test for YASA. So you can see that on their LinkedIn page and ask them questions there. But this proves the flexibility and the ability to improve this topology, because we're only 15 years in, right? Radial flux motors have been used in applications for decades. We're still kind of on the early end here. Another comparison, this highlights that step change in power and torque density. And this opens up opportunities for lift to weight ratios, which really weren't possible with previous technologies. And there's a general rule of thumb here that we like to talk to. So in the automotive industry, every pound of weight you take out of the e-motor, you tend to be able to save another pound through the balance of the powertrain system. We believe this rule also applies in the aerospace market, and weight's an even greater premium here, I would argue. And so we're demonstrating the weight of our EPU solutions to be nearly half that compared to conventional radial flux motors, which is a significant impact for any aircraft, but it's an absolute game changer when you're thinking about something with 6 or 8 or more EPUs per aircraft. So a higher efficiency propulsion motor gives, just to talk about that 5% and the equivalent 5% that comes from the other end, you get a lever to pull when you reduce the propulsion system. So that's either efficiency or perhaps a reduction in weight. So the aircraft gets more efficient or less weight, and either one improves the capability of that aircraft. So we've demonstrated 90 Newton meters per kg at the system level. So that's a packaged EPU electric engine with the MCU and power densities there that exceed 10 kilowatts per kilogram. So comparing that against other industry conservatively provides maybe 40% improvement on specific power. And if you take that number and use an example of a small eVTOL, 4-passenger, about 2 tons, it's pretty easy to see that 5% reduction in propulsion system weight. And this weight reduction is further compounded at the system level. So you reduce the weight of that motor, that reduces the aircraft weight. So then you need less battery storage, which again reduces weight. Iterating on the airframe, which requires less power to lift, then the motor, conductors, and distribution system can be optimized and reduced a bit further. And that goes on and on. So we presented specifically on this topic in the past, and we have some in-house system level optimization tools that can justify this assertion, and we have some real world data to back it up. So you can expect another 5% out of that airframe by optimizing, or say by the step change that we enable. So a 10% aircraft weight save is a game changer. So whether that's used to increase the range or load capacity, in some case that may be enough to make or break a business case. I would love for people to challenge that. No takers. Okay, soon. Couple of images here just talking about the hybrid focus that has been emerging. I think 5 years ago everybody was talking all electric. I think the industry has sobered up a bit to today's technology and how to get the range that's needed to make the business case close, and hybrid is in vogue for sure. We've seen a couple of companies go and fly hydrogen systems, which we're really excited about. We have a couple potential customers that are working on that as well. But the best motors also make the best generators. So there's a couple of applications where you can take a piston engine, high power dense piston engine, or a turbine system. Specifically, if you think about a turbine that's already designed for helicopters, they're already quite weight reduced, and the speed range of the output shaft fits well with our motors around that 6,000 RPM range. So there are good applications where we can use either a parallel hybrid or series hybrid with our motors as a generator to optimize some airframes that wouldn't be viable otherwise. A quick overview of our product line. Some of these images are old, so bear with me. We are working on some newer images, but the size and performance is what we have in the pipeline today. So if you span from left to right, you're looking at larger, higher torque machines on the left and higher speed, lower torque machines on the right. So specific torque on the left, power density on the right. And so you're looking to the left for eVTOL direct drive machines or pusher props, in the middle for multi-rotor aircraft or perhaps generator applications, and to the right for ducted fans or higher speed gear reduced systems. In some cases, our machines, like that D250 machine, has been used in a gear reduced configuration because the power density is actually higher if you can go to 3 or 5 to 1 and drive a prop for vertical lift. So where power density, or I should say minimizing weight, is paramount, sometimes it still trades to use a gearbox. And so as far as which product lines will hit first, we have D500, D250 hardware available today. Some of that is flight worthy, some of that is not, depending on which variations of those machines. The sort of D500 Rev 2 or D800 machines will be emerging in the next year or two. D1700s on that same time frame. So we'll have demonstration hardware for those higher torque machines in the next, I'll say 12 months. And we're being paced towards certification by our customers. So we have, I can't say which, but we have 2 product lines towards the left-hand side of this graph, which will be going to certification in the next, I'll say 3 years. But of course, those are being paced by our customers. So we don't really own that. And when I say we're headed to certification, I'm talking part 33. So, we talked about retrofits earlier. We talked about Mosaic earlier. I think what that low end of the market needs is some certified propulsion systems that folks can go and use as a retrofit into their aircraft. And that doesn't really exist today. You can't really, I mean, magniX is maybe one example. there aren't so many options for systems you can go retrofit into an aircraft with a certified engine. So our goal is to produce Part 33 certified propulsion systems that can go into green aircraft or be used as a retrofit. Whereas some of the hardware that has flown so far has been, I'll say, certification has happened at the airframe, and we didn't do the Part 33 work there. On the topic of certification, I think it's worth taking a look at the comparison between some of the existing markets, CS23 versus CS25, and where VTOL fits in there. Because a lot of the safety requirements and complexities of operating a VTOL push it more towards the CS25 aircraft, while the cost and size of that aircraft are much closer to a CS23. And this is part of the reason that Evolito is targeting DAL-A. So although we want to be viable in that low end of the market, especially for VTOL customers, it requires safety much more like a CS25. So we need to be DAL-A to satisfy those customers. A CS23 is generally covered by the EASA basic category, where safe emergency landing can be adequate in the face of a critical system failure. So VTOL being operated commercially in urban air mobility, for example, or as an air taxi, are likely to fall into that enhanced capability where continued operation is mandatory, and you need enough range to complete the flight or return to origin. And that's what's driving the failure rates and criticality levels to align more closely with the CS25 aircraft class on the right. We anticipate relatively strict requirements at launch. The certifying agencies are going to have a microscope on everything. We're hoping that once these propulsion system solutions and aircraft types have been sufficiently proven with enough flight hours and high reliability data, perhaps there'll be some opportunities for reduction in complexities and further aircraft optimization. In one of the talks I did earlier this year, I referenced the PT6. That's a great example of an engine system that's been so reliable that they've had some of the regulators ease up on what the airframe needs to do to justify safe flight, because the reliability of that system has been proven to such a high level. Further to the point on criticality of motor controllers for eVTOL, the lines become a bit blurry between a FADEC, a flight control, a motor control, because the motor controls can directly affect stability of the aircraft and the flight control system of some of these aircraft types. Failure rates are being driven to a higher standard for multi-rotor eVTOL applications. So the takeaway here again is we're required to act as a flight control in some cases. We're required to act as a FADEC in others. That's different for each aircraft type. And because we're working on so many different aircraft types, we really need to be at the highest level for everyone. So DAL-A was the plan since day one. And now this is the point where I would normally play a marketing video, but I don't want to bore you guys with the same video you've seen a few times. It's awesome. If you haven't seen it, it is on our YouTube channel as well. You can go and see that video. It shows some cool videos or images of our production facility. And with that, I'll stop chattering at you guys and open for questions.
Outstanding. Thank you, Matt. That was excellent. I have a question or two, but I thought I don't want to hog up the airspace. Anybody else got one? Feel free to raise a hand. All right, I'll get started. Matt, we talked a little bit about offline. We were talking about hybrid architectures, and it sounds like we're both proponents of that. How does that interface work with a turbo generator? You're linking up with an APU type turbine or a piston engine. What's that interface look like?
I have a great answer for that. So again, I hate to reference YASA all the time, but jot this one down. If you go and look at the YASA website, they've got a Lamborghini engine that they show a great image of. So Lamborghini took a V12 engine, knocked it down to, I think, a V8 and slapped a YASA motor on the back of it. So the motor goes between the engine and the transmission, and it becomes a hybrid powertrain right at the engine block, essentially. And so now you've got a system that can run in reverse. So they've taken the reverse gear out of the transmission on that car. They run the motor backwards for reverse. So that's a great example of what you would do with a piston engine. So if you took an existing Rotax or a Delta Hawk, you could integrate our motor right into the back of the engine block or right on the back of it as a bolt-on and hybridize it there. In the case of a turbine engine, if you can see an image of imagine an image of an RR250 or RR300 helicopter engine, instead of that shaft going into the input of your helicopter gearbox, you essentially put our motor right there. So you're not even changing the turbine engine, you're simply bolting something onto it.
Very cool.
Yes, very cool. In some cases, our motor can become a starter generator as well. So I think in the piston case, it's really simple. Today, you've got a starter, you've got an alternator. We can become the starter generator for that system. So the overall motor doesn't actually get any heavier and you've hybridized it. Not always the case with a turbine, because a lot of those turbine systems would be a two-wheel where we'd be hanging off the power turbine. So you can't start it with us. But there are some single turbine systems where we could potentially do that through a gearbox.
Okay, and more important question, that hybrid Lamborghini, how do we make that your company car? I feel like there's no better demonstrator.
Hey, you're preaching to the choir. I'm a motor guy. I'm a car guy. People have been asking what I'm up to this weekend. I'm actually going to be driving an all-electric endurance race car in Colorado for the weekend, which I'm excited about.
Wow.
It's super low power. It's not going to be quick, but we're out there just to show we can do it.
That's super cool. Love it. I've got other questions, but did anybody else have any in mind? I was thinking about running a propeller and motor as a generator,
Yep.
and or functionally being used as an air brake. Is there any realism to that?
As far as can we do it with the motor, yes. But the harder question of does it work aerodynamically, I am the wrong guy. Master's electrical engineer, not an aero guy, other than stuff in the garage.
Well, there's complexity.
Maybe there's
there
aero
too.
folks on the phone who can answer that.
Yeah. You start putting too much resistance on propellers, that the aerodynamics behind that get very complicated very quickly.
I have seen some architectures where a lift and cruise aircraft can use the lifters in a bit of a freewheel to regen. So there are some fun ways to play with this, but that's really a question for the aero guys.
Yeah. It is exciting to have that option.
Yes. Yes. So things like being able to stop the prop rapidly. I mean, there's a bunch of stuff you can do with electric motors that you just couldn't do without them.
For sure. And above and beyond the redundancy. Hey, did you have a question or an idea, Ken?
Yes, I have a little question and a big question. The little question has to do with Andy's desire he expressed earlier to blow the wing of his conventional Cessna 172 with 20 or 30 or was it 50 electric motors so he can take off at the driveway at his house. Now, the torque for an axial flux motor depends upon the radius. But he's going to have to fit these motors into his Cessna 172 wing. How important is torque when it comes to driving a propeller as opposed to getting a car quickly off the line? And will small axial flux motors be practical for being embedded in conventional aircraft wings to blow the wings? That's my first question. And my second question, bigger question quickly, has to do with the hope I expressed earlier that folks who are unconstrained by certification requirements, the experimental aircraft community, might be retrofitting engines into existing aircraft early on and thereby normalizing electric flight several years sooner. So, but they're going to need reasonably priced electric motors, preferably axial flux electric motors. You mentioned scaling up production, which means, of course, cost efficiencies. And also, if axial flux motors are in vehicles, eventually there'll be dozens and then hundreds of these motors in perfect condition available from crashed cars, just like ICE engines are now, and available to aircraft home builders to use. So what are your thoughts on those two questions, if you would, please?
No, that's great. No, those are really good. So the prop drive question on that chart where I showed torque on the left and power density on the right, driving a prop, you're going to be in that sort of 1800 RPM, 2000 RPM range. So you're going to be towards the left-hand side of that scale. For a single machine to drive a prop on a traditional single prop plane, you're probably somewhere, I'm sort of guessing on the aircraft and how big it is, but somewhere in that 500 Newton meter to maybe 1500 Newton meter design, depending on the size of the aircraft. So the short answer is yes, a single motor can spin a prop that will propel an aircraft. No problem there at all. Which one you choose depends on the torque requirement. And so you asked, does torque propel the aircraft like torque propels a car? So the short answer is yes. Higher torque allows you to get power lower in the RPM range. Higher power requires spinning a thing faster, right? So power is over speed. So if you have the ability to spin a thing faster, like a ducted fan, you can go with a physically smaller motor and spin it faster. The torque of the machine is what physically sizes the machine. So with any synchronous motor, whether it's axial flux, radial flux, you get instant torque, and anyone with electric car can verify this. At 0 RPM, you have the same torque that you've got when the motor's spinning at full speed, with some caveats, right? There's knee curves when you hit back EMF limits and things like that. But as a general statement, the torque curve is dead flat from 0 until your high performance mode. And so will you be able to package this into an aircraft? I was at EAA and I had the opportunity to look into the front of, I was over at the Delta Hawk booth chatting with those guys, and that piston engine in the front of some of those aircraft, our D500, for example, is smaller in diameter than their engine is. So if you took a lighter aircraft, a single D500 is probably enough to fly that aircraft. If you need more, you can double stack them. That's one of the benefits of this motor topology. You can just stack another one in there. And furthermore, if like a D14 or D1700 size machine is still going to fit in that cowling. So it's not going to be too big a diameter for small aircraft.
But what about in
The
the
other,
wing for a blown wing application, fitting axial flow motor into the wings like Andy wants to do?
yep. And so that's again another great question. And in a blown wing application, I'm going to make the assumption that you've got 6, 8, 10 props, right? And so in that case, each prop's going to be quite a bit smaller and therefore require less torque. And so we'll be able to put a smaller physical diameter machine to spin those smaller props. So in that case, you may only need a 250 Newton meter or 500 Newton meter machine, and we're talking 10, 12 inches in diameter. So it's not a big machine. And they, in that case, you're only going to weigh 13, 15, maybe 20 kg per MCU, or per EPU rather. The short answer is yes, it'll be smaller than what you're used to.
And the second question, yes.
And so the second question on cost, because I alluded to, fundamentally we don't use high cost components. It's one of the things that took us 15 years to get to a viable topology here is getting the cost out of that machine, making it manufacturable to something that can be used in a Mercedes AMG. So the short answer is we should be cost competitive against anything out there. Again, because we're leveraging technologies that are scaling to 250,000 motors per year under Mercedes, we're using very similar operations. If you walk our factory, it's going to look an awful lot like the slightly larger YASA factory that's 15 minutes away. They are producing 20,000 motors per year in that facility. They're producing 250,000 per year in the new Berlin facility. We're not there yet, clearly, and we use slightly different materials because of quality and certification requirements. So our costs will always be higher than an equivalent YASA machine, but we should be very competitive against any other competing radial technology. As far as taking crashed car YASA motors and flying them, I'm hoping to do the same thing in my garage. I'm pointing towards my garage in my house. All the new AMGs will have anything that's hybrid or electric will have YASA machines starting, I think, this year, next year. So what you do with those machines from a junkyard is up to you, but please send me a text when you do that, because I'll be watching intently.
Hey, that brings us right about to time. And Matt, this has been an outstanding presentation. You've got some really, really great tech, and I'm excited to see it get integrated into your current and partners to be, and get it all flying. But congratulations on great work by you and your team.
Thank you, Andy. Thank you, everybody, for listening in.
Appreciate having you here.
Take care, everybody.